Gut health, part 2. So, now that we have an understanding of how the digestive system works, let's cover some of the reasons for digestive issues. Understanding how these things arise helps us better understand how we can fix the problem once and for all. Most digestive issues are functional problems where the anatomy can appear normal under scopes and imaging, but the function of the digestive system is compromised and must be addressed at all levels for symptom relief. So, we will cover reasons for digestive issues in this module. We will then follow this discussion with some general tips and habits to maintain good gut health in part 3. So, the why is important to better understand the symptoms and the best steps forward. As we reviewed in Gut Health Part 1, the body has several different built in mechanisms to prevent overgrowths and dysbiosis from happening. So, first, it produces stomach acid to clean organisms off the food we eat, since our food is never completely sterile. Second, it moves food through the small intestine relatively quickly. It should move through roughly 20 to 22 feet in 1 to 4 hours. That requires a lot of energy to do that. And this action prevents food from lingering and staying in the small intestine longer than it should. If it does stay in the small intestine for a long time, this provides a food source for organisms that shouldn't necessarily be living in this relatively sterile environment. So, quick movement through the digestive system is important. Number 3, it produces bile, acid, and enzymes to help our body break down food particles. Number 4, it activates something called the migrating motor complex, MMC, to produce mechanical waves along the intestinal tract to keep matter moving forward and sweep debris through the small intestine, cleaning up shop. And number 5, it keeps the ileocecal valve between the small and large intestine closed, only opening it to move matter through when needed to prevent backflow of bacteria up into the small intestine. So, we clearly reviewed that there are a lot of moving parts, and many life events or bodily states can cause issues at the weakest link along your digestive tract. So, in this section, we will discuss the following issues that can cause digestive issues: subclinical or clinical hypothyroidism, stress and decreased vagal tone, high PUFA consumption, nutrient deficiencies, low-calorie diets, undereating, low-carb diets, fasting, processed food, iron supplementation and iron fortified food, food poisoning, physical obstructions, processed food, childhood, and mold and biotoxin exposure. But first, let's start with the most important one. Let's pull in the thyroid connection to digestion, as a down-regulated metabolism and thyroid system is commonly the root issue for many digestive problems. Your entire digestive system has a very high rate of energy expenditure, since the acts of digestion and nutrient absorption critically depend on energy. In fact, the digestive system, which includes the intestines, pancreas, spleen, and stomach, contributes less than 6% of body weight, but can contribute up to 20% of whole body energy expenditure. And thyroid hormone sets the metabolic rate for every single cell in your body, and this includes every step and stage of our digestive process. There are now thousands of studies in the literature documenting the connection between digestive health and thyroid health. And while many of these studies are for clinical hypothyroidism, subclinical hypothyroidism will still manifest as some sort of digestive issue, maybe not as severe, since any downregulation in systemic energy production will negatively impact digestion, a very energy-intensive process. So here's just some examples of connecting thyroid health to gut health as documented in the literature. First, gut health lining. The length and thickness of the intestinal villi, which determines the thickness, permeability, and strength of the intestinal lining, is impacted by thyroid health. Here's a quote from the literature. Quote, "In hypothyroidism, the intestinal villi were short and the intestinal wall, muscle layer, was thickened, thereby increasing intestinal tone, leading to reduced intestinal motility." End quote. Not what we want. Active thyroid hormone T3 is a critical regulator of intestinal epithelial and gut mucosal development, differentiation, and homeostasis. Number 2, gut motility. So hypothyroidism leads to slower gastric emptying times, and this is well documented, and we include links to these references in the module script. So one study compared hypothyroid patients to a healthy patient, and they compared various levels of emptying and transit time. So first, esophageal emptying. The healthy patient had 90.13%, whereas the hypothyroid patient only had 57.83% emptying, meaning there was still food sitting there, not what we want. Comparing the esophageal transit time, the healthy patient, it only took 21.5 seconds, whereas the hypothyroid patient took 50.5 seconds. Again, the longer something takes to move through, the more opportunity there are for overgrowths. And this one was huge. The gastric emptying time. The healthy patient was 28.43 minutes, whereas the hypothyroid patient was 79.48 minutes. So here's a quote from that study. Quote, hypothyroidism affects the entire gastrointestinal system and causes hypomotility. End quote. Thyroid hormones are known to influence gut motility by modulating the ENS and altering smooth muscle function and the MMC, migrating motor complex, essentially downregulating the motor activity of the digestive system. Slowed motility can quickly lead to digestive issues, as the slower your digestion, the more food your bacteria gets. So the more time bacteria has to ferment the food, more negative symptoms you will get. And this slower transit time often also results in constipation, which is the most frequent gastrointestinal complaint in patients with clinical and subclinical hypothyroidism. Now, on the flip side, thyroid hormone treatment has been shown to improve symptoms and increase motility. It's been shown to enhance MMC contractions. In fact, one study documented larger and longer duration MMC contractions with thyroid hormone administration. So better MMC contractions means more food moves through the digestive system completely, and we have better cleanup. So also connecting thyroid hormone and digestive health, we can talk about digestive enzymes and bile. So research shows that low T3 level leads to poor stomach acid secretion. And thyroid health is intricately connected to liver health, and thus the amount of bile your body produces and releases. And then if we talk about dysbiosis, thyroid system is linked to the composition of the gut, meaning the health of one's thyroid system will impact microbiome balance. And dysbiosis is very common in those with thyroid disorders. So I share all of this again to remind you that fixing how the body functions at the energy systemic production level will improve gut health. Every part of the digestive process requires cellular energy, so every part of the digestive function can be impacted with low energy production. So subclinical or clinical hypothyroidism, and thus hindered energy production, is one of, if not the root cause of digestive issues. Unfortunately, thyroid health and gut issues are bidirectional, meaning one impacts the other. While a sluggish thyroid system may be the root cause of your issues, your digestive issues, like a high bacteria and endotoxin load or overgrowth, may actually be holding your thyroid back, acting as your current energy block, making it a negative spiral. For example, if we aren't extracting nutrients and energy from our food, this will limit the tools and building blocks our thyroid system needs to improve systemic energy production. Or chronic constipation can lead to more and more overgrowths. And even more, a high level of inflammation or endotoxin load can limit T3 production. This is why, in many cases, the overgrowths and the sluggish metabolism thyroid system must be addressed in parallel. Overgrowths can be treated, but thyroid function must be addressed in order to actually prevent reoccurrence from happening. So I think we clearly established thyroid and systemic energy production are one of the main reasons for digestive issues, but now let's cover some more, which all negatively impact metabolic rate and thyroid health. Next up, high PUFA consumption. PUFA referring to polyunsaturated fatty acids. Again, all foods are a combination of different types of fats, but some products are significantly higher in PUFAs relative to others, and it's really the ratio that matters. And so this is going to include vegetable or seed oils, raw nuts and seeds, fish oils, etc. Remember, PUFAs are unstable molecules. Saturated fats, on the other hand, are stable and protective. They do not oxidize and cause systemic damage like PUFAs do. Let's look at a few studies. omega-6s, which is a type of PUFA, have been shown to harm the intestinal wall integrity by reducing the height and width of the villi that line the gut. They increase tight junction permeability, which is not what we want, thus increasing the body's exposure to endotoxin. They alter the gut microbiome and induce dysbiosis and gut inflammation. PUFAs exacerbate the endotoxin problem by accentuating oxidative stress, whereas saturated fats are protective. Saturated fats reduce oxidation and combine to endotoxin to help detoxify and inactivate toxins. So here's a few quotes from the literature, and I'm not going to include all of them. You can check out more in the module script below. Quote, we demonstrate that unsaturated fats by itself result in dysregulation of intestinal tight junction integrity, leading to increased gut permeability, end quote. Another quote, the corn oil diet, rich in omega-6 PUFAs, increase the potential for pathobiont survival and invasion in an inflamed, oxidized, and damaged gut, while saturated fatty acids promoted compensatory inflammatory responses involved in tissue healing, end quote. And remember, omega-3s are PUFAs too. While omega-3 PUFAs may lead to short-term inflammation reduction, this is due to immune suppression, which can eventually lead to other health complications down the line. A few quotes from Dr. Ray Peat, quote, in declaring EPA and DHA, which are omega-3s, to be safe, the FDA neglected to evaluate their antithyroid, immunosuppressive, lipid peroxidative, light sensitizing, and anti-mitochondrial effects, their depression of glucose oxidation, and their contribution to metastatic cancer, lipofuscinosis, and liver damage, among other problems. Omega-6 and omega-3 fats are unstable and produce a lot of toxic free radicals in our bodies in the long run. You can't and shouldn't try to avoid them entirely, as they're present in animal fats, so it's impossible to eat 0 grams, but don't go out of your way to add extra to your diet and do what you can to reduce your consumption of them. Next up is low-carb diets. So it is very common in low-carb diet spheres that people only poop, every other day or every 3 days. And even though some may not be bloated since there aren't many dietary fibers, this doesn't mean you aren't efficiently removing excess hormones and waste or magically stopping bacterial fermentation. You likely are not. Low-carb diets can be helpful in the short term, but long-term cutting carbs is a band-aid approach to avoid dealing with the slow metabolism. It's not fixing the underlying metabolic problems in low energy state. We've discussed this extensively in the course. Low-carb diets increase stress hormones, and there's an abundance of research showing that low-carb diets result in reduced active thyroid hormone T3, increasing thyroid-blocking hormone reverse T3, and reduces metabolic rate and energy production, all of which will negatively impact digestive health in the long run. A lowered metabolic rate is going to continuously hold one back from improving overall gut health. And proper carb utilization has a number of gut-specific benefits. First, glucose protects the gut endothelium against stress and maintains gut barrier integrity. Second, carbohydrates are necessary for producing protective gastrointestinal mucus and as an energy source to maintain adequate gastrointestinal function. And third, low-carb, high-protein diets favor a pathogenic and pro-inflammatory microbiota profile with reduced short-chain fatty acid production and increased ammonia, phenol, and hydrogen sulfide production, driving mucosal inflammation and other intestinal issues. So restoring a healthy oxidative metabolism and improving energy production sparks the digestive system. Remember the Dr. Ray Peat quote, energy and structure are interdependent at every level, end quote. So the proper functioning of your entire digestive tract requires adequate energy production. Another culprit of causing digestive problems is low-calorie diets. Chronically undereating is not a good signal to the body. It signals scarcity, and many bodily functions like digestion will be downregulated since these are technically non-essential tasks. The body will prioritize the limited energy resources to prioritize essential tasks like keeping your heart beat. It is now well documented in the literature that a low-calorie diet can cause GI issues. The digestive process requires energy to function. Now, I'm not saying you can never eat in a caloric deficit for fat loss, but a planned fat loss phase with a dedicated amount of time, say 8 to 12 weeks, for example, is very different than chronically undereating, always eating low calorie. Next up is fasting. Fasting is not going to fix your digestive problems, and it's not a magical cure. Fasting may give you short-term relief, no doubt, since you're no longer digesting food, but the act of fasting is not going to boost your metabolism. It is well documented in the literature that fasting will lower metabolic rate, since not giving your body food is a signal to the body that starvation is coming, so we should lower metabolic rate to conserve energy. It just makes sense. With the lower metabolic rate, the digestive machinery is down-regulated, and your gut health will be worse off in the long run. Remember, extremes may come with short-term symptom suppression, but always come with long-term consequences. It's very common for people to develop more and more food intolerances as they continue to fast. There's no doubt that many people may experience digestive relief relative to a crappy diet, but you can experience the same digestive benefits while not stressing your system out by fixing your gut and metabolism and prioritizing easy-to-digest food and fibers that work well for you. And I'm not saying that you should be snacking and grazing all day long, but eating 3 meals a day plus a snack, that's totally fine. But you don't have to go out of your way to fast. Next up, stress and vagal tone. So stress diverts resources away from your digestion at every level, and this is a protective mechanism by the body to conserve energy for the threat or incoming emergency. Under stress, you produce less saliva, less digestive enzymes, and less stomach acid. Stress decreases gastric motility, increases inflammation, and increases intestinal permeability. When discussing stress and constipation, it's important to discuss the vagus nerve, as this helps better understand why stress can be so damaging for digestion. So the vagus nerve is one of the 12 cranial nerves in the body that is used to counteract your fight or flight system. The vagus nerve is the longest nerve of the autonomic nervous system that comprises both sensory and motor fibers to help control involuntary bodily functions. It carries sensory fibers that interface with the parasympathetic control of the heart, lungs, and digestive tract. So the vagus nerve connects the gut to the brain, and vagal intervention is necessary for dampening inflammatory responses in the gut and maintaining gut barrier integrity. In fact, vagal activity and stimulation has been shown to reduce the inflammatory response to endotoxins, which are like bacteria biotoxins. So high chronic stress will lead to reduced vagal tone, and a potential consequence of vagal nerve fiber loss or low vagal tone is slowed motility, particularly in the stomach and top part of the small intestine, since the upper digestive organs are mainly innervated by the vagus nerve. The migrating motor complex, MMC, also depends on vagal integrity. Next up, low vitamin D. Vitamin D is an essential vitamin that's actually classified as a steroid. It is now known that at least 1,000 different genes in the body are regulated by activating vitamin D, specifically 125O3. And since so many people spend most of their days indoors and have very little sun exposure, vitamin D levels are falling. But elevated vitamin D levels are good for the gut, and here are a few reasons why. First, it induces antimicrobial peptide gene expression, giving it antibiotic-like effects. So normal or high vitamin D levels allow your body to release optimal amounts of antimicrobial peptides that help keep bacteria, fungi, etc. in check. For example, many studies have shown that the higher someone's vitamin D level is, the more likely they are able to eradicate H. pylori and prevent it from coming back. Low vitamin D is actually reported in 60% of IBD patients. Number 2, vitamin D improves the composition of the gut microbiome with more beneficial bacteria that can produce more B vitamins for us, and they require vitamin D. Number 3, elevated vitamin D levels reduces excess serotonin production, which we have now covered is not good to have in excess. And as a result of those 3 items, elevated vitamin D levels will lead to less inflammation and better gut integrity. Next up, nutrient deficiencies. So your body obviously needs energy and micronutrients to function. For example, fat-soluble vitamins affect several components of the mucosal barrier. Epithelial cells and several types of immune cells in the gastrointestinal tract express vitamin D and vitamin A receptors. And in vitro studies show that vitamin A and vitamin D modify the expression of tight junction molecules. Vitamin B1, it plays an important role in hydrochloric acid release and gut motility. Vitamin B3 plays an important role in helping the body break down and get energy from the food we eat. Another example in regards to gut health is acetylcholine, a neurotransmitter used by the parasympathetic nervous system, aka the rest and digest part of the nervous system, to slow the heart rate, dilate blood vessels, encourage gastrointestinal tract motility, and empty the bladder. Well, acetylcholine production requires B vitamins and vitamin D. And the B vitamins not only play a role in assisting with digestion, but there's also some data showing that various microbes in our gut produce some B vitamins, suggesting that a healthy, normal intestinal microbiome may serve as a primary source of B vitamins. Regardless, proper digestion requires B vitamins to perform various functions, so ensuring that we are regularly eating nutrient-dense foods is important to support proper gut functioning. Next up would be a diet high in processed foods. So long periods of eating processed and crappy food can also negatively impact the gut, as many additives and ingredients can disrupt the gut lining. First, emulsifiers. So detergent-like food additives ubiquitous in processed foods include carboxyl methylcellulose and polysorbate 80. These can damage the intestinal barrier and increase intestinal inflammation. Second, vegetable oils ubiquitous in processed foods, as we've already discussed, can disrupt gut barrier integrity and increase inflammation. So another concerning ingredient is carrageenan, which has been shown to increase intestinal inflammation. And here is an alarming quote from Dr. Rapey. Quote, "In the 1940s, carrageenan, a polysaccharide made from a type of seaweed, was recognized as a dangerous allergen. Since then, it has become a standard laboratory material used to produce inflammatory tumors, immunodeficiency, arthritis, and other inflammations. Unfortunately, it has also become an increasingly common material in the food industry. Carrageenan enters even the intact, uninflamed gut and damages both chemical defenses and immunological defenses. When it has produced inflammatory bowel damage, the amount absorbed will be greater, as will the absorption of bacterial endotoxin." End quote. So we do not want more carrageenan in our diet. Another common ingredient in processed food is red food dye, and synthetic red food dye disrupts the gut barrier and increases serotonin in the gut, increasing the susceptibility to intestinal inflammation. Another ingredient is synthetic citric acid. Citric acid occurs naturally in some fruits and vegetables, and that's fine, but the manufactured citric acid that is used extensively as a food and beverage additive can be a powerful inflammatory agent. Most of the manufactured form is made from GMO mold. Quote, "Manufactured citric acid is a ubiquitous substance and one of the most common food additives in the world. Approximately 99% of the world production of citric acid is through microbial processes using predominantly a mutant strain of the black mold Aspergillus niger since 1919. When the FDA adopted the Food Additives Amendment in 1958, certain additives were granted GRAS, generally recognized as safe status by the FDA due to lack of demonstrated harm over a history of prior use. Thus, citric acid was considered GRAS and did not undergo any FDA evaluation. Citric acid is one of the most common additives used today, with applications ranging from food to non-food industries. It is estimated that 70% is used in foods and beverages." End quote. There's a few other studies or a few other quotes from the literature included in the resource module, but I don't think that we should regularly be consuming something that contains citric acid. And then artificial sweeteners are now very common, but they've been shown to alter the gut microbiome and can negatively impact MMC function. So these are just a few of the chemicals and toxins in our food supply that can damage gut health over time with consistent use. Moreover, processed food is just often low in nutrients, leading to nutrient deficiencies. Next up, iron supplementation and iron fortified foods. So excess iron in the gut can negatively impact the gut microbiome as pathogenic species use iron as a food source. Here's a quote from the literature. Quote, "There seems to be a negative correlation between lactobacillica and bifidobacteria, two beneficial gut bacteria species, with dietary iron and a positive correlation with selenium and zinc. Particularly pathogenic strains grow well in heme-rich conditions due to their efficient heme capturing ability. Many enteric gram-negative bacteria, including Salmonella and pathogenic E. coli, require iron for their virulence and colonization. Beneficial commensal gut bacteria from genera Lactobacillus and Bifidobacteria, on the other hand, require less or no iron. Administration of iron supplements due to incomplete absorption of around 20% increase colonic iron, leading to adverse effects in altering the microbiota. In vitro and in vivo studies propose that through oral iron, the beneficial barrier of commensal gut bacteria is decreased and the abundance of enterobacteria, such as pathogenic E. coli, is increased, implicating gut inflammation. Reflecting back on my childhood, I remember eating cereal pretty much every day, and with most non-organic flour, these are fortified with iron shavings. So we don't need to go out of our way to eat a bunch of fortified iron food. Another thing that can obviously cause gut problems is repeated bouts of food poisoning. And this can be problematic since E. coli, Salmonella, Campylobacter, they produce a toxin called CDTB, which can damage the gut by damaging vinculin. So vinculin is a protein in the lining of the intestinal tract that connects a network of cells that signal the coordinated wave-like contractions of peristalsis. So frequent damage to vinculin can stall gastric motility. So definitely need a little extra support with repeated bouts of food poisoning. And obviously there are some more rare things like physical obstructions. So an intestinal obstruction is when there's physical material blocking the normal flow of food through your intestines. And this is likely triggered from an event such as abdominal scarring from surgeries, hernias, an injury in your midsection from an accident. And this would result in rather severe symptoms like pain, strong cramping in your belly, throwing up, and really, really chronic constipation. So an event such as this can definitely cause digestive issues in the long run, as periods of being backed up can cause bacterial overgrowth and dysbiosis. And this would likely require medical treatment and intervention. Another thing less discussed is biotoxins. So mold and other microorganisms produce chemical substances called biotoxins for chemical warfare as a defense mechanism. So when in a clinical or subclinical hypothyroid state, which many people are in, high exposure to these biotoxins from chronically living in a water-damaged building, for example, can definitely lead to low MSH. And low MSH levels can then lead to a widening of the tight junctions in the intestine, increasing intestinal permeability, aka leaky gut, thus exacerbating the inflammatory cycle. So it's important in conditions like this to, of course, work on improving your thyroid and systemic energy production so that you can be a little bit more resilient to these things, but also reducing your exposure in parallel so that your body doesn't have to work as hard to boost your metabolism when in a state like this. Unfortunately, glyphosate is another thing that is a common reason for gut problems. So glyphosate is the main ingredient in the weed killer Roundup, and it's now the most widely used chemical herbicide in history. It's not only used as an herbicide on GMO crops, but it is also sprayed on some grains and crops as a desiccant in order to speed up the drying process, pushing harvest up a few weeks earlier. And this can be on non-GMO grains and crops too. It doesn't have to just be on GMO because non-GMO still allows plenty of pesticides. There's now an overwhelming amount of evidence that glyphosate damages our guts. Glyphosate is an herbicide designed to kill weeds and microorganisms. Well, we have microorganisms in our gut. It's been shown to hinder the growth of beneficial gut bacteria and promote the growth of pathogenic bacteria, inducing dysbiosis. Quote, glyphosate residues on food could cause dysbiosis, given that opportunistic pathogens are more resistant to glyphosate compared to commensal bacteria, end quote. In the Human Microbiome Project, 732 out of 941 bacteria species have at least one copy of the gene that glyphosate targets. So the intrinsic sensitivity of our gut bacteria to glyphosate was found to be 55% sensitive, 38% resistant, and 7% unclassified. Here's a quote from that study. Quote, the EPA, the Environmental Protection Agency, the acting executive agency of the United States, has the highest acceptable daily intake for glyphosate globally, currently set at 1.75 milligrams per kilogram body weight per day. For comparison, the established limit in Europe and Canada is 0.5 and 0.3 milligrams per kilogram body weight per day. However, only direct glyphosate toxicity was considered. Alarmingly, glyphosate's influence over health through secondary means such as the gut microbiome was never considered in these reports, end quote. So this not only involves individual grain products like oats, corn, wheat, barley, etc., but also food products made from the grains like cereal, bread, baked goods. Think of how much non-organic cereal you may have eaten growing up. A Swiss agency survey tested breakfast cereals, and 8 of 10 samples had glyphosate residues that were above the limit of quantification. So this not only involves food products, but also alcohol, which is, I think, one of the biggest issues with current modern day alcohol. Quote, glyphosate has been detected in beer and wine samples, and residues on grains used for beer or grapes for wine are the probable sources, end quote. It's no wonder why so many people have gut issues, as glyphosate is almost ubiquitous in this day and age. So there's clearly a lot of factors working against us, and someone's gut issues could be a result of some combinations of the items discussed. But we are not forever doomed. We just need some course correction. So the next module, Gut Health Part 3, will discuss some general gut support tips that can finally help you move the needle forward in improving gut health.